let's go from top to bottom. So the form is standard, yes, because of the A plus B. There's A, B, and C. Okay, A, B, and C, and vertex. Okay, the vertex that you want to get quickly. I don't know how you got 3 right away, but I think you know how. But you have to get your y. Let's see if it's 3. You remember how to do it? It's negative b over
It's
2.
negative b over 2a.
A. Yeah. So this is the vertex. I'll go ahead. Not let me. Yeah. So I can speed things up. So is it negative 3? I'm sure it is. So negative 1.
Oh, is it negative b?
Yeah, it's negative b.
Negative 3.
Negative. Yeah, it's negative b over 2a. So it's, the b is going to be 6. Sorry, I think that I made a mistake there. So it's going to be negative. It's not I don't know where I got the a from. Okay, so negative b. So it's negative 6. I'm plugging in over 2 times negative 1. So it is going to be 3. That means you just got the x coordinate. So you have to get your y. So all you do is just plug it back into the y. This is your y. So plug it back in. So it'll be 3 squared plus 6 times 3 minus 1. So you get negative 9 plus 18 minus 1. So this will be 9. 9 minus 1 will be 8. Is that okay?
Okay.
So that means you want to fill in 3 comma 8 and then plot that right away. If you should. So 3 comma 8. Let me see here. Sometimes I can't see. 5, 6, 7, 8 right here. That's it. Yeah, double check. Yes, 3 comma 8 right there. That's your vertex. You could do V right now just to make note. And axis of symmetry. Do you remember? Because
Is
you can
that
answer
x
that right now.
equals 3?
Yes, it's the x coordinate of the vertex. Yes, immediately. Now, here's the thing. If it's negative, do you remember the shape of the parabola?
It's pointing down. Right?
Yeah, so it's going to be something like this, right? But that to get like the some points, I don't think you need to do a table because you're asked to find x-intercept and y-intercept. That means you could connect to them, to those intercepts, and then that's good enough. So, and then we can, do the rate of change and decrease and all that because, yeah, you have to get all the details to get the graph, basically. If you get the graph, you can answer all the other stuff. But let's see your y-intercept. I think you know how to do that. So y-intercept means you x equals 0 and you got it. So it's going to be negative 1. So let's see here. 0 comma negative 1 right here. So that's your y-intercept. What about your x-intercept? You okay with the y-intercept? Right?
Yeah.
Yeah, you put 0 here and 0 there. Therefore, you're only left with a negative 1. X-intercept. How's x-intercept for you? Right, let's do x. So x-intercept, you go like this. So I'll label what I'm doing here. X-intercept I'm doing. You solve, you set y equal to 0 and then solve for x.
Oh, yeah.
Yeah, so the reason is because anytime it goes through any points on the x-axis, you don't know what x is, but your y coordinate is always 0. That's why you substitute it with 0, y, for the y. Is that okay? That's the reasoning behind it. Now, from here, you attempt to actually factor if you can. You don't want to do anything fancy, but before you factor, I recommend you get rid of the negative here. So you divide everything by negative 1. Including 0. That's, you want to be consistent with your algebra. So it becomes 0 equals x squared minus 6x plus 1. And then you could do whatever method you want, the x, whatever the x method, that way you organize things, or you go ahead and try to guess the combination if possible. Oh, this is not good. Because even if you try to do the x method, it will not work. So you have to do quadratic formula. You see why? Yeah, this is not fun. Let me double check my math here. Yeah, you have to do quadratic formula. Double check. Oh, I didn't know I can do that, by the way. If I hold it. Yeah, wow.
Oh.
Okay, that's cool. Okay, anyway. Okay, so quadratic formula. You have to fill in the blanks. So do you remember your formula? It's negative b.
Negative b over, negative b
Plus or minus.
square root plus or minus the square root of b squared minus 4ac divided by 2a.
Yes, very good. All divided by 2a. So my writing is not nice. Okay, so that means you could have actually used the negatives, the original, but it doesn't matter. Either one is going to work. So let's, you know what? I recommend you use the original. Is that okay? Yeah, use your A, B, C from here. So your A, your B, your C. So, okay, let me go. Negative B is positive 6 plus or minus 36, 6 squared, 4 times negative 1 times negative 1 all over 2 times negative 1. So it becomes negative 6 plus or minus 36. I recommend you just, 36 plus 4. Double check, sorry. So
Negative
it's
4.
negative 4. So it becomes 32 all over negative 2. Yeah, it's not nice here, but here's the thing. Yeah, you have to simplify it because you have to fill in the blank. So you remember the root of 32 is the same thing. Root of 32 is the same thing as root of 16 times 2. Yeah, sometimes you're not sure, just kind of do your prime factorization or whatever you need, okay? So that means to rationalize the root, it's going to be 4 root 2. You okay with this? 4 root 2 coming from there. Because root of
4
16
or
is
2,
4.
yeah.
And divided by negative 2. Now, the fast way to clean this up, because you can divide the 2 into both of them, or just go ahead and divide everything by negative 2 or something like that.
Okay.
What do you think? Now, here's something going on here. If you divide, yeah, this is fancy stuff that you're doing. If you divide a negative into this number, it will flip flop. I don't know you remember ever seen that before. It will flip flop the sign. What is that? What that mean is that
What does that even mean?
I know. It means that, okay, how about this? Let's don't do it like that then. You might want to do something like this, but some student will attempt to do it. You can go ahead and write them separately, 1 plus 1 minus, and then go ahead and clean it up. What I mean is that like this. Watch. Here's the first one. Then it will clean it up with all the numbers as is. We're going to go with the plus one first. So this is what I'm going to show you here. All over negative 2. Then the other one is the minus. Then you clean it up from there. That makes sense, right? I hope minus 4 root 2 divided by negative 2. And then then we'll clean it up. So to clean this up, I don't know how you normally do it. I would divide into both of them. So it's going to be 3 minus 2 root 2. That's one of them.
Yep.
And the other one is going to be 3 plus 2 root 2. So that means the answer that you put in here, are you going to write it as a coordinate like x comma y, or do
Yeah.
you? Okay, that means we're going to do 3 plus or minus. Okay, now we can do the compressed form, plus or minus 2 root 2. 3 plus or
Oh,
minus.
okay.
Yeah, you can do it. Yeah, you can do that. 3 plus or minus 2 root 2, sorry. 2 root 2 comma 0. Now, if you wonder what that looks like, you may want to use a calculator so that you can approximate. And it better be consistent, meaning that it's going to kind of have to go through somewhere here and here, so that it become a
Yeah.
parabola. So let's quickly look at it just to be sure that we did it right. Calculator here. Sorry. Come on. Okay, so I'll do 3. I'll do the plus 1 first, 2 root 2. And then I'll go and, come on, give me, thank you. I can, so this is the first one. So it's 5. That seems right. So approximately 5.83. So 5.83. 1, 2, 3, 4, 5. So it's almost 6. So there's your first x-intercept right here. But then if you want to see the second one, it's going to be like between 1 and 0. So watch. I'll go ahead and bring it in and then put a subtraction in between here. There it is. It's going to be 0.1. So it's close to 0. So we got it right for sure. Oh, I'm sorry. You don't have to write the decimal values. Go kind of graph it. Is it okay? Just pretend you graph it. I don't know. You need to label it. I don't think so because you already got it here. Is it okay? Just
Okay. Yeah.
So there's a 0.1 and a 5.8, and then just connect them. Yes, just sketch it. I can do better, but it's okay. It's supposed to be a
It's
little
fine.
bit. Yeah, it's supposed to be a little bit
Yeah.
more bowy right here. But that's it. And then now you can start answering all these characteristics right here. Domain. Any parabola, it's all real. Can I
Okay.
write it this way, or do you want negative infinity,
Yeah.
positive
No, that's
infinity?
perfect.
Okay, good.
That's
And
fine.
the range, you have to look at it from top to bottom. The highest point is 8.
8.
that means you want to do 8 down, but you have to write it from left to right in interval notation like this, including 8. You okay with that? Yeah. You in interval notation, you have to write the smaller one first, comma the biggest number.
So why for range do we have to do the bracket thing? Because I never understand that.
Okay, the bracket means you include the number 8. Is that okay? Include the number 8. If this were open, like you've seen like open dot before, like that.
Yeah.
It's kind of cut through, like something like that, right? It means you have to parenthesize it.
Okay.
Yeah, but there's more to it because we are about to answer this question right here. You're going to get confused in a
I don't
second.
remember how to do
Yes.
increasing or decreasing.
Okay, I'm going to show it to you right now.
Okay,
So,
fine.
yeah, this is where, okay, yeah, this is where it might be the most confusing. But okay, the bracket that you using is because you're including that value 8. But sometimes you don't include it. You might have come across it in piecewise graphs and all that. You've got one open, one closed, and all that. Yeah. So that's, yeah. Now, increasing and decreasing, it goes like this. When you look at the graph, you have to scan from left to right like a book. You cannot pick however you like. You got to read from left to right. You got to scan from left to right. That's the only way it works. And you need it for calculus if you are going to take it, next year and in college or whatever. So when you going to have to find increasing or decreasing, you have to scan from left to right, any graph. So if you scan from left to right, if you notice that it's going up like this and then it's going down like that, but the way it's going up from where to where? It's from negative infinity all the way to here, x values. So increase, decreasing are x values. So let me see if you're going to be okay. So the way you're going to write this is that it's increasing from negative infinity because the way it's coming from way over there. You just don't see it. If you continue the graph, it's going to cover all the negatives. Infinitely. So the way you write is that from where it's increasing and where it's going to stop, it's going to go like this from negative infinity all the way to x value here, 3. But here's the confusion part. When you do increasing, decreasing, you should never use the bracket, but sometimes they do. The teacher even make mistake. You don't use the bracket. The reason why is because you're about to do decreasing and using the 3 value, you cannot share the same value. That's why they math people kind of agree upon don't reuse the 3. So therefore, it's like an open dot when you doing increasing or decreasing, but you don't write the open dot. The way you express it is like an open dot. Okay, anyway, decreasing. So if you continue from 3 on, that's when it's decreasing, right? See, continue scanning. So therefore, you're going to have to write 3, but don't include it because you didn't include it here. Therefore, you don't include it here. So from 3 on to infinity. So that's your decreasing.
So the increasing, decreasing refers to the x value.
Yes. Yes.
Okay.
The increasing, decreasing are x values. That's it.
So would the... Wait, never mind. Wait. Yeah. Now I got it. Yeah.
Now, max and min are easy, but let me answer the rate of change. Do you remember what your teacher said?
It varies.
Yes,
It's always going to be
that's it.
varies.
Yes, because it's not a straight line. Is it varied or varies?
It doesn't matter. As long as it's not like a specific number, they're not going to care.
Okay. Now, max and min. Normally, it's actually the y value, but I don't know. But there's a way to write it correctly, but you're not going to like it, though. Then the max, there's no min, first of all. So I don't know, NA, none.
That's fine.
Okay, none. Max, because it's concave down, it's like hilly. You can see like the hump upward. That means you have one. So the max is right here. Normally, it's at you write the y value, but I don't know what your teacher want. You could write the coordinate.
I think she just wants like the number. I think.
Okay, so let me see. In pre-cal textbook, it goes like this. It goes like this. You're not gonna like it. At x, something like this. Y equals 8. At x equals something like this. At x equals 3. Or you want the coordinate. It's the same thing, right?
That's weird. Yeah.
8. You don't have to write y.
They just
8.
want 8.
Okay,
They just
8.
want 8.
Yeah, the y value. Okay, 8. Everything else, you think you're okay? You seem to have everything filled up.
Function is like the vertical thing, and the
Yes,
other one's like horizontal.
Yes. I can say this. All the thing that you do right now, they're all functions. Yes, for all of it. Every single one of them. Yeah, even single one of them.
I think I wrote that. Oh.
Yes, yes. Okay. Shall we go on to the next page?
Yes.
Which one? Page 2 or?
Sure. Let's just see what's on page 2.
Is this page 2?
So page 2, the like word problem stuff, I do not get that
Okay.
at all.
Okay. Now, then you have this. I think you can answer that now, right? Increasing,
I think
decreasing.
so.
Yes. Okay.
Yeah.
Okay. Right now, let's see. It's a little blurry, but okay. It's not. There's nothing to it. Okay. It's just you have to follow this equation. But let me see. A toy rocket, just in case there's something more to it. But really, I don't even read it. I just go and use this. But let me double check. If the toy rocket launch vertically upward, it's going to shape like that. That's a parabola. It's like concave down like this. So that's
Okay.
what they're describing. If you graph it, you'll see it upward from ground level. Okay, I'm glad I read this because this is going to be something, may be something that you're going to need at the velocity of 128. So it's already in the equation. So that's the 128 there. And the feet per second, don't worry too much. But when you write the answer, your unit has to be sensible. But we'll see. Then its height h, it's given here. So that's the h of t with respect to time. Like as time passes, it's like
Okay.
f of x, h of t.
Mm-hmm.
So t is in seconds. Okay, got it. Okay, this is very easy. Let's see. Now here we go. A, how long will it take the rocket to hit the maximum height? Okay, so all you need to do is find the vertex, the x coordinate of the vertex. Do you remember? Let me write this here. You know, like it's x comma
Oh, it's
y.
the negative b over 2a.
Yep. Yeah, but you see why you're using the x because it's the t. That's the time. Think about it, right? You see that? So therefore, you want to show the order. You go like this. You write t instead of x. T equals negative and b over 2a. But let's just use it. B will be 128 over 2 times negative 16 2a. And then just do the math here. So it's 128 divided by 36. I don't know what that is. 128 positive divided by, so 32. Sorry, not 36, 32. Four times. So it's going to be 4 seconds. No kidding. Yeah, so that's the answer. Wow. Okay. So 4 seconds is the time it's going to reach maximum. So it's a rocket, so it shouldn't take that long. 1, 2, 3, 4. Anyway,
So, wait, is there any other shape besides a parabola that it could be? Like, how would I assume that it's a parabola and I should use the negative b
if
over
you see,
2a?
I'll say this. If they ever ask you, okay, good question. No, if you see x squared, it's going to be parabola or t squared.
Okay.
So, but the problem will never be anything other than a parabola for a problem that looks like this. So, if
Oh, yeah, I
if
see.
I can make a guess, the test will look just like this one, except the 16 would change, the 128 would change. Yeah.
Yeah, no, it's
It'll-
like the rest of the
yes.
problems are the exact same thing except like different numbers.
Yes. That's exactly. Now, well, you got 6. That's fancier though. If you get confused, I'll help you there.
Yeah,
But here,
I did not know how to do that at
okay,
all. The
okay.
teacher was sitting next to me doing that.
Okay, I'll try to reinforce it. I know that sometimes it will go over your head a little bit too, but yeah, you may need a second source or more than that too, even sometimes. Okay, are you okay with the A?
Yes.
Yes. Now the B, guess what? You use the 4 and
The
plug it back in.
vertex?
Yeah. So it's
Okay.
going to be the Y value, of the H. So
So
if
it's
you
like
want
the
to,
vertex of the parabola
yep.
in that sense.
So
Okay.
if I were you, I would just do the math like this, and that's it. The H of 8. So the math is going to be negative 6. Oh, sorry, not 8, 6, 4. H of 4. You know what I mean? Like you plug in the 4.
Mm-hmm.
So the H of 4. And you just show the substitution right here. Squared plus 128 times 4. Whatever this is your answer. But you want to write the unit being feet. Yeah, so let me say negative 16 times 16 plus 128 times 4. I got 256 feet.
Uh,
Double check if you need to, but I think I'm okay. 128.
256, yep.
So that should be the max height. Okay. All right, now C. How long did it take the rocket to reach the ground? Now, if I were
And
you,
that's the x coordinates?
Uh, actually, actually, the easiest way, since this is a parabola, but it's not real in real life, you just double this here. You know, when you went halfway 4 seconds, the other half is going to drop down, so it's going to be 4 times 2. It'll be 8 seconds.
Wait, what?
Wait, let me show you. If I draw the picture, you understand it. Now, if not, you have to actually do the math. Like you could here. I'll show it to you. It's not going to be fun, no. Let me double check. Yeah, so it's not going to be fun. So the answer, the fast way is that like if you go, like the shape, the rocket goes up like this, and then it come back down like this. If you remember from A, it says how long will it take to
Oh, it
reach the
takes 4
max?
seconds.
4 seconds. That means the other half is going to be 4 seconds. So it's going to be 4 times 2. But let's do the math that your teacher may want you to do. I'm sorry,
Is that
8
like
seconds.
the quadratic formula? I'm
It
right?
goes like this. The logic, it's this. It's like, when the height is, zero, it's when the t is going to be your answer, because when the height is zero, it's when it reaches the ground. Think about that. See that? When the h being zero. So therefore, if you want to prove that it's 8 seconds, you may have to do it. So you're gonna substitute h with 0, and then you solve it by factoring.
Oh, so it is the x-intercept. So
Yes,
the A
yes,
is
yes, yes,
the
yes, yes, yes.
x value in the vertex, B is the vertex, and C is the x value.
Exactly. That's
Okay.
it. But the answer that you're gonna get from here is one is 0, the other one is gonna be 8. But let's kind of see it. Factor out. So if I do the math, it will look like this. Factor out the common factor, which is gonna be negative 16t. Is a common factor. Let me pull this out quickly. So common factor for that. So 128 divided by 1664, I think. 8 times. Sorry, I should know that. So anyway, so 60 times t will give you negative 16t squared. Negative times what will give you positive would be minus 8. There. You see that? It's okay? Then
Yep.
you set each one equal to 0. We already know the first one is when it starts from the ground. So that's why it's still going to be 0. T equals 0. So therefore, t equals 0. That's the first one. But you don't care for that. T equals 0. The one that you're going to care for is t minus 8 equals 0. It's t equals 8. So there. I think your teacher may want you to show this. But if you want to be clever, you could go and double it. I think your teacher will be okay with that too. 4 here, and then 4 here. So anyway, it's seconds. Yeah, make sure you write seconds here. Unit.
Okay. Oh,
All right.
yes.
Yes. All right.
So 6, I don't get either. I mean,
Okay.
even though I have work, I was just copying off the board. I don't know what
Oh,
I'm
I
doing.
see. Okay. So the key here is you have to be able to sketch. It's not that bad. Let's take a look quickly. It's distracting me here. Okay, let's see. So to make an enclosure for chickens, so it's a rectangle area with a fence next to a house. So okay, this is very popular. It's common. I don't know how you want to draw it. So here's a house. You can think it's a roof here. I'll even draw a little 3D, but looking down. Okay, let's pretend you're looking down. But the fence. This is like the roof. When you look down, the fence will be here, a rectangle right there. Okay, that's the fence. But then, so that's just a sketch. That means you're not going to have one side. You don't need that because it's already part of the wall of the house. So you don't need to worry about the fencing there. So the fencing is going to be here, here, and here. Is that okay? But then let me see the details here. Only 3 sides will be needed to there. So they even tell you, I already know that. Yeah, I already know that. 1, 2, and 3. Is that okay? So they're trying to be detailed about it so you don't miss anything. And then, okay, now, and then it says there are 120 feet of fencing material. What that means is that this, and this add up to be 120. Is that okay? But the way you figure that out is this way. Let me show it to you right now. Is that okay? Okay, now, there are different ways to do this. I'm going to do it the traditional way. Okay, I don't know what your teacher wrote there, but I'm going to go the way that I think what the book would do. I'm sure she does the same thing. I'm not looking at her work, so it go like this. If you go with the XY configuration, like your XY axis, that means this will be your Y, this will be your X. Now, it does not have to be that. If you don't like it, you don't want an X to look like that, then you don't have to. Let me see what she does here. Yeah, you see, she didn't do that. So okay, look, you know what? I'll do what she does because if you know how you go up and you go to the side is like x, the up is y. So believe it or not, this is what pre-calc and calculus is mostly like. But therefore, let me go ahead and do what she does so you could get to compare. So I'm going to do x and x, and then I'm going to call it y. Now, if you wonder why are you choosing x and y? You don't have to. You can choose a, but a has to be here and a has to be here, and then b. No kidding. Okay, you can choose anything you want, but the only thing that you have to make sure is that this has to be different than that because one is longer. Is that okay? So one is longer. So she choose x and y. So I'm gonna go with that. I wouldn't know if I were to do it myself. I would do y and then I would do x always based on the xy plane. But let me see. Okay, so we're gonna do that. But let me see what else do we need. What is the dimension? What dimension will maximize the area? Okay, got it. So here's how this works. So there's two things you have to do. You just cannot do any shortcut on this. So it's something that you have to be able to like go through in exact. It doesn't have. Oh, sorry, the order doesn't not matter. You just have to actually be able to come up with both of them. So what I mean is this. Let me write the easiest one first. The fencing, like the side that goes like from here to here. You remember? It's x plus y plus x equals 120. Do you agree? Because it describes the material around it. So there you go. So you can write that and then clean that up a little bit. So it's 2x plus y. It doesn't matter how you clean this up. It goes to 120 and kind of wait on that. Now, you may need to actually, solve for one or the other in a moment. It doesn't matter which one. I'll be honest, but let's go ahead and put that on hold. But you're not done. You're not done here. You may have to solve for y, but we'll see in a second. So you just kind of gather information. This is the way it's very common even when students don't remember you don't want to memorize anything. Just do like what makes sense to you, and then you kind of continue with it. So, but then there's one more. This has to do with the perimeter, by the way. It's a perimeter concept.
Yes, it's the perimeter.
Yes, the perimeter concept. Then you have the area concept because you need the area concept because it's the main equation. It says right here. What will the dimension, be that will maximize the area? So the key word here is the area that you have to set up. So the area of this shape is a rectangle. The area now we can think of like space there. It's x times y. Or y times x.
So are we solving for the perimeter or the area?
We're solving for area. Your final equation is going to be about the area, but you're not solving for the area. You're solving for the x and y because look, it says right here. How do you know what I'm solving for? The thing is that you have to look carefully. You should use grammar dimensions. Yes. Okay. So you have to look for the grammar. Yeah, it has to do with the grammar part here. So the dimension is what you're looking for. So dimensions, that means it's like the sides, So all you need to do is, hey, just get you x and y. You don't even have to say anything more. That's it. The x and y will be done. If you get the x and y, basically they're the dimensions. Okay, but then you can't do it without the area. Okay, now how do I continue? Now, normally it's this way. Like you got the last one, h of t, f of x. This case, most commonly, it's a of x. Okay, so a of x. So you have to write everything in terms of x. Now, here's where it's not going to be fun. If you do that, there's two versions. The version that's easiest based on the x and y. See, maybe I should not have chosen the y being here. Should have chosen x there. You would like it better, but it might not look nice or familiar to you. Watch. This is one version. This is another version. This is another version. This version is easiest because if you look at it, if you solve for y, you don't have any fractions. You just subtract both sides by it. You see it?
Yeah, that looks.
So let me show you what that looks like first. If I solve for y, okay, solve for y, and I'll plug it back in. So everything's in terms of y. So first, let me double check. Yes. Actually, I take that back. I apologize. I apologize. No, I said it right, but this is not nice. I see now why she shows that. Okay, first of all, she has the solution guide, so she's already ahead. Why she already know what to choose? So don't worry. So it's not. She saw the answer already ahead. So, okay, so this is the right one that you want to do. Here's why. If you leave the x alone, like a of x, and just leave the x alone, so you're not gonna deal with the x. So you're going to keep the x, but the y, you're going to solve for it in terms of x. So subtract both sides. That's why this works. So subtract both sides by 2x. So it'll be 120 minus 2x. So if I do that, I'll be able to plug it in here, and everything is now going to be in terms of x. Oh, here it is.
Okay.
So that's why she shows that, I see, because she saw the solution already. That's why. But if you know, like you're a little bit more comfortable, you can do any x or y, it doesn't matter. There it is. So you're pretty much done, but if you want to continue to make it look like a quadratic equation, you can. So it'd be 120x minus 2x squared. It goes to a of x. And this is your equation you're going to continue working with and work with. There it is. Now, if you have that, you're pretty much ready to finish the problem. So here we go, continuing on, right?
Mm-hmm.
Let me see. What is the dimension that will, maximize the area? So you have to, okay, first of all, I hope you're okay with this.
Yes, I'm good up until here.
So when you grab this, it will look something like this. It doesn't have, don't worry too much about where, where it's going to be x-intercept, where it's going to be intercept. It seems like it might be intercepted like in the first quadrant, like right here and here. Don't worry. Okay. Now, okay, from here, you have to figure out where is the area being the highest value. Wait, first of all, for me to explain this, right? You got the area equation. What do you do with that? What does that mean, right? It means that if you graph it, this is the easiest way to understand. If you graph it, it will shape like this. Okay? But when it's shaped like that, that means if you make sense of it, the y axis is now a. You get it? Like it's a value. But the x is still going to be x. X-axis is still going to be x. This is the part where if you get it, then it will start making sense. This is your a of x is like your y, so it means that the y values are your a, like all of this will be your a values. But you need to associate to that, because for you to be able to continue on. Why? Because once you get the highest value of the a, imagine that for a second. Once you get the highest value of the a, that means you maximize it. That means you got the highest possible area values. So if you read the question, it says, hey, how could you find the dimension when your area is pretty much at max? And I know it doesn't work exactly that way, but this is math phrasing, like the way they term it. They call it maximize. But what it means is really the same thing as, hey, what is your high, when you have the highest area value, the a value, what is your x value? Why do you need to solve for x? Because that's the only value you can find other than the area itself. Okay, I know this is confusing a little bit. I know it. Okay, for example, I'm making this up. If the area the a, that's the highest point, is 800. I'm making this up. It's the area of 800 something squared. What is that? Feet squared something. Is that okay?
Yeah.
That means if you find it to be 800, that means you know what it is. It's your vertex. You use the vertex. Actually, you have to use your vertex before you even get the 800. So if it's 800, that means you know what x is, because you know that's the vertex, like the vertex, the x coordinate, x equals negative b over 2a. That means you got one dimension. You're done at the highest area value. Is that okay? That you can get. But okay, let me do it the way that you continue on with. Okay, from here, let's go back. From here, you have to picture this. Your teacher did not actually, I'm sure she didn't actually do it this way, but she got to here for sure. The next thing she has to do is explain what the shape of the graph looks like. It should look something like that. Okay. So once you imagine or see it, all you need to do is now find that a equals negative b over 2a. The x equals negative b over 2a. Why? Because that will give you the x coordinate of the highest value of the parabola. The highest value is called the maximum value of the area. And that's exactly what you're supposed to find.
So now we're finding the vertex in the sense.
Yes. Why? Because, okay, let's do it. Let's do it. I think it will make sense more if you see the value. Okay, here we go. Negative b, it would be negative 2. Oh, no. Negative 120. No. Negative 120. negative from the formula, but the b is just 120. Do you see it? If not, you rearrange it. Negative b, negative 2x squared plus 120x. Reorganize it. Remember a, b, c.
Yep.
Okay. So here's your a and here's your b. So then 2 times negative 2. Okay, here we go. So the answer is going to be positive. So 4 in the denominator. 4 can go into 12. 3 times, so it's 30. So the x, we got one dimension right now. But why? How do you know that's the answer? That's one of the answers. How do you know that that's done? Well, if you plug it back in, it will give you the highest a value. You agree with me on that, right?
Yes.
Yeah, you give you the highest a value because of
And
the way
then-
it's shaped. And that is the
do we need to
maximum.
punch the 30 into
Yeah,
the
we have to put
equation?
we have to put it back into to get your y to
Oh,
finish.
the original one.
Yeah. For the y, whatever it is. So you got the x check mark, but you need the y because that's the component of the dimensions of any shape, right? Like I'm sorry, a rectangular shape. So this is one of them. I think it's in feet, right? Yeah, I think it's in feet. Yeah, it's in feet. So that's one. Now you have to solve for y. So you go 120 minus 2 times 30, and then you're done. So the answer is going to be 60 for the y. So it's really 30 by 60 or 60 by 30. That's it. Those are the dimensions. Yeah, we're done.
Okay.
Now,
Wow.
one last time. The reason why you're doing this is because if you know the shape, that's where the highest a value is. That's why it's maximized. That's why it's the highest a value you can get. That's why you're doing the whole thing this way. Just the vertex. But you can't get the vertex without the parabola, right? That's it. So you have to come up with this parabola or the quadratic to get you a, b, and c. That's it. I know it's like a lot. You know, that's a lot here. There's a lot of step by step. But the reasoning
It's
is
a lot
key.
of stuff, but
Yep.
it makes
Yep.
sense why you would do it.
Yes, exactly. Okay, good. Number 7. Okay, this number 7 is going to be easy. It's going to be the same as number 5. Let me double check. Yep, yep, it is because you're actually now starting from the ground again. It's implied because you know it's implied. That's it. So okay, but the thing is that what is the maximum height? All you need to do is solve for the for the t and then plug it back in. So for a, you need to get t first, negative b over 2a. Then you plug it back into your h of t, and that will be your answer. This is the answer. Check in feet of t. You get that? Is it okay? You do that. Your a will be here. Your b will be here.
Okay.
And then let me see the b. Will you be able to dunk the basketball? Let me see.
I don't know.
Wait, let me see. You need to jump. Okay, yeah. You have to figure out whether the height is actually going to be 2.5 at least. Wait, let me see if you okay. For example, if a person can jump up 2.5 feet, now what's the height of this person? It doesn't tell you, right? Yeah, it doesn't. Oh, this is not okay. There's more to it. When you jump, here's the animation. If you start from the ground, if you can jump above, he needs to jump 2.5 feet in the air to dunk the ball. So once he jumped, he'll be like, pretend this is about 2.5 here. So he's now up like right here. This is his feet. 2.5. You okay? That's like the height. So if the person jumped, I'll even do the hand like this. So he jumped up. It'll be 2.5 feet here, like that. I think there's I think something is missing here because you don't know the person's height. How do you know you're going to be able to dunk the ball? Wait, do I miss something? Tell me if do you know if there's a person's height here?
I can check the answer.
Okay, wait. I'm sorry. Forget it. You know why? Because I didn't read carefully. The function h happens to be the height of the parabola below him. You see this?
What?
I know you're tired. This parabola function has to do with the height below his jump.
Oh, it's the parabola of his jump. Okay.
His jump. Yep, the parabola of his jump. Yeah, so all you do is you still do this whole thing, do vertex formula and plug it back into the h. If it's 2.5 and above, then yes, including 2.5. Is that okay? So if it's 2.5 and above, then yes. If it's below 2.5, then no. It has to be exactly 2.5 or above this here. Let me write it. If it's greater than or equals to 2.5, then yes. That's it. Yeah, so the height of your feet are above the ground is given. That's it. So this is exactly that's why it makes sense.
Okay.
Okay. What about 8? Okay, 8.
Eight's the pool. It's like the fencing again.
Okay, I wrote over this thing, but let me see here. Oop, I
I
can't
wrote
erase
it
that.
down if you want to.
Okay, yes,
You
let
like
me,
undo or.
I have to go into the layer. Let me see. I'm not that great here. No, because it's on the same. Yeah, I can't undo it.
Aw.
If I undo it, I could. But you did you copy all this
Yeah.
already? Okay,
Yeah,
if
I
you
did.
copy it, so let me undo it. Yeah, it has to be greater than 2 or equals to 2.5. Okay, there you go. So the person's feet is here. Okay. All right. Let me see. This distracting me here. Okay. Sarah has an outdoor pool measured. Okay, I'll sketch that quickly. So it's going to be 25 and 10 here. FT. She wants to add a cement walkway around the pool. Oh, okay. I see. So I'll just go over it. I already know what it's going to ask here, but let me to do this. I'll tell you because okay. Let me see. You're going to be okay. I'm drawing the frame. I know I already had the picture there, but I had to redraw it just
Okay.
quickly. So here, a 3D. I'll try. Here we go. 3D like that. 3D like that. Okay. So this is 1 for sure. Now imagine this is 3D. Okay. Here even draw. I even do it like this. Check it out. I even do that.
Okay. Awesome.
But it's not the pool. Okay. It's not inside the pool or anything. It's just the material that you need. So okay, 1 here. But then how do you do the rest of it? Well, it's 10 here. We know that 10 here. We know that it's 25 here. 25 here. But that means this is going to be x, and this is going to be x, and this is going to be x, and this is going to be x. Okay, so if you were to actually do a what do you call it, a volume formula for this picture, how do you do it? The volume of this whole thing, based on what we're doing here, the volume of this whole frame, including the inside, is going to be 25 plus 2x times 10 plus 2x. Okay, so far. Okay, times 1. The whole thing, including the inside here.
Okay.
But then how do you cut it out? You're gonna do it like this. You're gonna subtract 25 times 10 times 1. Let me see you understand that. This is gonna be, I'm pretty sure, I'm like 100% sure this is the setup. The whole picture without the inside. Let me see if I can draw that. Without the gap inside, it will look like this. And then I'll subtract it from there. But it will look like this, right? The whole thing without it being cut. It's going to be 25. The frame is 25 volume. Remember, length, width, and height. 25 plus 2x. Remember we were doing that earlier. And this is going to be 10 plus 2x here on the side. I'll write it sideways. 10 plus 2x to the side. And then 1 here.
Okay.
So the volume of this whole thing is this right here. Let me see if you're okay, right?
That makes
Length,
sense.
width, and height. Okay, but then you have to cut the inside out because you only need the frame. The frame is the walkway with 1 inch, 1 foot thick. See that? But we don't know what x is because that's the width of the surface, the width around the pool.
Okay.
You see the picture there? So therefore, if you subtract it off, it will look like this. This shape represents this whole thing. I'm pretty sure.
Okay.
But do you understand why I subtracted like 25 times 10 times 1? Because inside is 25 times 10 times 1. And then this will be equate to the material you need is 304 cubic foot, and then solve for x, and that's it. Let me use Wushram to do this quickly. Do you know what I mean about Wushram? You can foil it, but I'll go ahead and it's a program that I here. You want to see it? I can do it. Wushram. So I don't have to foil it. Pretend you did this by hand, okay? Because what was that? 25x. I'm sorry, 25 plus 2x.
Plus 2x. 10 plus 2x.
10. You can see what I'm doing here, right? 10 plus 2x
Times 1.
times 1. I'll even do that. So that is going to be the first part. Right here, the expanded form. You can write that down. 4x squared plus 70x plus 250. Let me, did you get that? 40x, 70. Okay. Was it 40x? I forgot what it was.
I thought it was 4x.
4x plus 70x was,
Yep.
what was the last?
And then
Plus 250? And then minus 250. Is that true?
Minus 250?
Yeah, that means all you need is this equals to 304. And then subtract 304 over. Do you see what I did, right? I subtracted 250 from. So let me double check. Yeah, this is timing 1, okay? Let me double check the equation here. Yeah, 70 and 250, yeah. Okay, and then subtract, because you have to solve for x, and then you'll be done. Subtract 304 equals 0. You can do quadratic formula. So let me actually see what it looks like if I were to do that here. See what it looks like, the answer. So that, because you already know the answer, right? X squared plus 70x
minus 304.
Minus 304 equals 0.
Or equals, okay.
Equals 0. Okay, let it solve. You can look up this thing in the online. It's free online. It's like a website.
Oh, really?
Yeah, you can punch in and check your work. Okay, what is the answer?
The answer is approximately 3.6 feet.
There it is, 3.6 feet. Look at that. Use your quadratic formula. Okay, look, you see the answer right there. Use your quadratic formula. One answer will be 21.0. You see the bottom here?
Oh, so it's a quadratic formula.
Yeah, you have to use quadratic formula to solve it. Done.
Okay.
There you go.